Hey everybody, I'm Karl Weinmeister. I'm with Google's developer relations team. I'm visiting you all from Austin. Happy to be here. We've heard a lot of great talks today and yesterday about building models, everything from feature engineering, time series forecasting. What I'm going to talk about is once you've built that great model, where are you going to run it? That's basically the focus of Kubeflow, an open source project for deploying models on Kubernetes, a container-based orchestration platform. Good to go. So basically, I'll walk through sort of the problem. Why are we here? Why should I care about Kubeflow? Some of the goals in the project, that sort of guide the principles and architecture, things like that. We'll get into the components, the user interface, sort of the command line, how do you use it. We won't get too deep into DevOps stuff, Docker things, stuff like that, but you'll get a feel for that, a little bit how to use it hands-on, and then I'll do a brief demo. Okay, so the problem, especially if you're new, you're coming to data science there's so many different ways we've all come into the field. Maybe you were a developer that worked with other languages and you started to learn Python and you start using pip and conda and virtual environments, and it's just kind of overwhelming trying to get everything right, much less, I want to use a GPU and I want getting the package dependencies right. If it's in production, that's a whole nother story, working with other team members, ensuring that you have a consistent environment. Finally, even bigger challenge is trying to reproduce the same environment locally, on the cloud, on premise, or even across different clouds, giving you that ability to port your solution in a consistent way. So those are the problems that we're aiming to address. So some of the quotes that we've seen guiding the project, this isn't comprehensive, but I think these are a few good examples. Traditionally with ML workflows, we've kind of just taken existing software development workflows and kind of bolted on some ML. We haven't necessarily taken a step back and looked at some of the DevOps practices we use for software engineering and applied them to machine learning, things like CI/CD for as you're making changes to your models, ensuring they don't regress, things like that. Model freshness, that's a huge issue. You build a model based on certain conditions at a point in time. Things change, the outside world changes, people change, all kinds of things. Whatever your model is based on, you probably want to think about what's your strategy for retraining it on a regular basis. So that's something that Kubeflow can help with. And finally, reproducibility. This has just been a huge topic in the AI field recently about holding ourselves to a high standard when it comes to validating our results, showing how we got there. A very famous conference, NeurIPS, is now requiring all papers actually follow a model reproducibility checklist. So ensuring that the data, the source code, the hardware specs, all that is very clear and known so you can reproduce your experiments anywhere. So I kind of took just a simple kind of the different layers of reproducibility, get into that a little bit, from a paper, State-of-the-Art Reproducibility in Artificial Intelligence, just the different layers of it. So with the method, that's really hasn't been much of an issue. That method layer is essentially the problem, the objectives of what you're trying to solve. That's generally consistent. The data, being able to show your results, your training data, your validation data, all of that. And finally, your experiment, and this is where I think that there's been a sort of lack of tools for this, is what source code was used, what are the different experiment runs, what's your accuracy for each of them, really kind of being able to track what you've done in a reproducible way. So with that, I think this is all just kind of reinforcing the point that when we think about data science, we sometimes think it's just building a model. That's the one big activity we're doing. As we all know, there's data issues, but it's part of a much bigger picture that if we're putting something in production, we have to get all of this right. getting the data ingested properly, transforming it, validating it, so on and so forth. The model building is super hard to get to that level of accuracy you need, but not sufficient. Here's a view from an architecture perspective. All the different things that you need to be considering when you're setting up your stack, the model, your tooling, frameworks, CPU, GPU, TPU, all these different configurations, getting that right and consistent. And you have to take that workflow from data science and sort of apply it to that. Oh, and it's not just a one-time thing, right? You're constantly setting up and tearing down these environments, different team members having these environments. So hopefully this has helped kind of motivate why this matters, getting a consistent and reproducible environment. And here's where Kubeflow comes in. So I'll just kind of read this because I think it really packs in a lot of the key concept. So it's all about making it easy for everyone to really do the whole life cycle from development, deploying, and managing after you've deployed it, and ensuring it's portable and distributed. It's all based on top of Kubernetes, so it's standards-based, the same infrastructure that the developers at your company may be using. You can put your machine learning stack in the same place and take advantage of its distributed nature to scale out to as big of a cluster as you want to finish your jobs quicker. The design principles are this low bar and high ceiling, which might sound a little contradictory, but it kind of really means as a data scientist, maybe you don't care about all the minutia of Docker and YAML and containers, and we're really trying not to expose all that, trying to just have a good default implementation to just use it and share it in your organization, but also a high ceiling because we know that a lot of times customization is needed, extensibility is needed, so everything about the project is open, you can tweak it, you can do things like the out-of-the-box Jupyter Hub image, you could change it and use that instead of the one that we provide. So it's kind of trying to address both of those needs. So in the end, it's a curated set of tools and artifacts for machine learning running on Kubernetes. I won't get into all the different components, but this is just kind of a quick survey. Everything from training, serving and prediction, to your model development, so a Jupyter environment, Jupyter Hub environment there, hyperparameter tuning, so you have an ability to kind of run what we call study jobs, that kind of run a bunch of jobs and show you the accuracy of that. Pipelines, that's what I'm going to demo today. That's what kind of wires together all the different components into a reusable workflow. And several other key components. Pipelines are end-to-end ML workflows that allow you to track your job. So you basically, in Python, there's a language, I'm going to show that in the demo, and you can kick off a job, and you'll see the different steps, the accuracy, all the statistics about it in the GUI when you're finished running your pipeline. So what it actually is a pipeline, you might ask? It's a containerized implementation of an ML task. What that basically means is we'll take your Python code and put it inside of a container so it can be run on one node or it can be scaled on multiple nodes. You specify the steps in Python, and then you can run it. And what's kind of neat about it is it can be parameterized, meaning that you can pass in different parameters like how many epochs do I want it to run? What's my training set? So you can choose sort of what level of flexibility you want so that you don't really have to get into the code to change different ways that you run your experiments. So in summary, Kubeflow is a cloud-native, multi-cloud solution for ML. The pipeline component sort of sits on top of that and wires together your different Kubeflow components. And if you have a Kubernetes cluster, you can just install Kubeflow on top of it. So let's talk about the user experience, kind of end-to-end, what this looks like. I'll first just talk about how do you install it. For Google Cloud, there is a user interface, but I wanted to just kind of show the general command line that any cloud or a local deployment can use. It's called kfctl. Like if you ever use Kubernetes, there's the kubectl, which is for deploying Kubernetes stuff. So basically, I'll just walk through a little bit of code, but some commands, but it's fairly straightforward, I think. You init to kind of set up your one-time setup, put in your platform, the name of your application, and then generate platform. Basically, anytime you run generate, you're creating the scaffolding, but you're not actually deploying it. So here, the platform is about setting up your cluster. If you already have a cluster, you don't have to do this step. And then the Kubernetes step is for generating all the services that run on top of your cluster. And that's basically it to get it installed from the command line. Once you're running, the dashboard looks like this. The dashboard is kind of just like a landing page with the different tools in Kubeflow, and we'll also see that today. If you want to start a new Jupyter notebook, it allows you to pick a custom image or one of the built-in images that might have a certain version of TensorFlow or PyTorch or whatever framework that you want to use, and you can specify, does this cluster have, does the notebook server have GPUs, CPUs, how many, and all that. So and you could do that and spawn a new server for yourself. That's what Jupyter Hub looks like. How do you actually deploy your code? So I'm going to show a little bit about what's happening under the surface. There's a nice new SDK that we added in the version that came out this week, but I think it helps to kind of understand a little bit what's happening behind the scenes. So if you've ever worked with a Docker file, a little crash course in Docker here, what you see here is at the top, you're basically extending a base image that has a certain configuration, like a Linux with here's a version 1.8 of TensorFlow. And then you'd have a few lines to specify which Python packages, a line to copy your training files into the image. You build it on the Docker command line, and here we're pushing it to the container registry. So it's accessible from your cluster anywhere else. So then basically you have a containerized version of your Python training code. How do you configure distributed training? So we have a component out of the box called a TF job. We also have a PyTorch job, Chainer, and some other frameworks. This looks like a lot of stuff, but I think the key concept is that there's something called KSonnet, which is a tool for basically templatizing Kubernetes resources. And you see a bunch of param statements. So we're creating a TensorFlow job, and we're setting, which like the sample size, the storage bucket, it's going to pull the training data from, things like that. So you can just customize it however you want. And there's also a user interface for this. But this just kind of shows you an example of using a component, parameterizing it. Note we haven't done anything with it. We're just kind of setting up the job. Here's where you deploy it. Again, the apply command is what actually pushes your code to get it going. Here's a quick crash course on some Kubernetes commands too, like kubectl here, getting the pods, and we're basically looking for a pod with the name of the app you start. So this is what you'd run to see, hey, is my job running? You can basically list the pods, looking for that. Finally, how do I see the logs? As I'm running my training jobs, I want to see, what's the loss? How many epochs has it gone through? That's where a command like this would come in, where you can actually see the logs in the pod that you're running your job. Okay. Finally, so we've gone through the deployment and training. Now let's talk about serving your model. So you've created a model. There's a serving component that basically wraps your model into a REST API that's stored in the cluster. And so this is similar, where you're generating a component using the TF serving template, setting some different parameters on it, and then applying it. Okay, so we kind of walked through the traditional approach. We have, and sort of here's one of the problems that it's the new library called Fairing solves. This is a little bit of an oversimplification, but this idea of think about 3 different paths, right? Your local code where it's just Python, you do some training, prediction, you run the main method, and you train it. If you happen to use, say, Google Cloud, we have some command line utilities, again, and you run it with some training code. a different approach. And then sort of like a third approach with Kubeflow. You never really have to mess with the YAML code like this, but this is all basically built out by those templates that we saw in other slides. But this just kind of gives you a feel for the 3 different ways that you can deploy. With fairing, it abstracts some of that detail away. By importing the fairing library, you basically have a backend, and you can have different variations of it, a Kubeflow or local or Google Cloud. And so you can kind of use the same code and train and deploy it to an endpoint all within a Jupyter notebook. So the advantage here is, this is getting back to the low bar concept. Maybe you don't want to build a Docker file based on your Python code in your notebook. You can do this all within the notebook itself, and this will package your code up, put it into the container, deploy it. So it's kind of doing all the steps that we showed on the past few slides, all in a few lines of Python code. Okay, and then you're done. Basically, you've got your REST endpoint for a model, and you integrate into your application. All right, so let's do a quick demo. Okay, so to deploy it on GCP, we have a user interface that you specify a few things like your project in GCP, some authentication stuff, which zone you want to go in, which version of Kubeflow, and you create it, and it basically sets up the cluster for you, and you're off to the races. So assuming that you've done that, I'm not going to do that now. It takes 5-10 minutes, something like that. So assuming that you've already installed it, here we'll take a look at what it generates. So with the Kubernetes engine, you can see that it's created a cluster, and within that cluster, you can see just some of the configuration information, how many nodes are in it. All this can be customized after you've installed it. Another view here on services kind of gives you a feel for the breadth of things. I know that's a little hard to see from the back. The breadth of services included in Kubeflow. So there are things like Jupyter, Kotib, which is our hyperparameter tuning service, web UI, things like TensorFlow jobs. It's sort of all different services within your Kubeflow installation. Okay. All right, so that is kind of what it looks like in GCP. Now let's fire up the actual dashboard. So this is the 0.4 dashboard, 0.5 that came out this week. It was significantly enhanced. So anyway, just FYI, this bright orange look and feels changed. So here's an example notebook. So I'm running Jupyter Hub within my Kubeflow cluster. I've created a kind of very basic model. I wish that I had known about the profit framework that I remember from the first day's talk. This was the reason I picked this. This is in Austin, there's a 311, kind of like for non-emergency type of calls. Reason I picked this was this is publicly available data, and it's kind of like time series data, and it's, I think, a good example of you need to retrain your model all the time. So this is just predicting like how many calls are going to come into the call center based on historical data. I create a super basic model. It's still actually surprisingly close. What month did the call come in? What day of the week? Is it a holiday? That seemed to predict a lot. It wasn't a recurrent neural network or anything. I was just kind of a quick example. Focuses less on the model and more about the infrastructure in this talk. So wanted to see how do you actually define a pipeline? Okay, so I'm going to skip past some of the imports and things like that. This is going to have 3 steps. I've kind of is there quite? Oh, I'm sorry, it's a little hard to read. Yeah, thank you. Thanks for catching me on that early. Any better or? Okay, hopefully that's okay-ish. Yeah, so basically 3 steps in this pipeline. Straightforward example: download the data, train it, and then deploy it. So we're using an out-of-the-box component. So Kubernetes comes with all kinds of components, things like the Apache Beam data processing, several Google Cloud components, other clouds are some contributed components as well. This is doing something very basic. It's just running a query against BigQuery, one of our public data sets that has this Austin 301 information. So just have a query that grabs the different service requests, counts them, kind of groups them by day. So that's where I'm trying to forecast the number of calls per day. And the component really just runs the query and puts a CSV into a storage bucket. That's all it does, and that step is done. The next step is training the model, and that's where I pass in some different parameters, what version of TensorFlow, and finally deploying the model. Deploys the model. So let's look at the pipeline and how these things are wired together. This is a little verbose just because I was trying to kind of follow best practices and allow everything to be parameterized so that once I create a pipeline and I want to run it a little differently, I haven't hard-coded certain values within my Jupyter notebook. So if I wanted to change the region or any of that, I could change in the Kubeflow GUI dynamically. I'll still pass in defaults, but I can change those. So let's look at those 3 steps. So there's basically 3 tasks that we talked about: download, train, and then here I specify dot after the download task. So that helps the compiler wire these together in the right order. On the next phase here where you deploy it, notice I didn't have to say the deployment is after the training. That's because I referenced one of the outputs from this part of the process. So it kind of inferred what the order was. So that's basically it for creating your pipeline. It uses a component that compiles it and puts it into that YAML format. You don't really have to worry about that. It's sort of behind the scenes stuff. And then finally submitting the pipeline. So here we're running it, and it creates a nice little link for you here into Kubeflow, into the pipelines interface. So there is our workflow with 3 steps. If you click on any of the different steps, you can see the artifacts from it, the inputs and outputs that belong to each step, and logs. So here you see things like, okay, it ran the query, looks like everything was okay, not a ton of detail there. Let me adjust the screen size a little bit. Let's look at the training step. What's kind of cool here is that you can do things like you can see a rock curve, or you can see a confusion matrix. There's components that kind of look at different model runs and look at their accuracy. In this case, I can look at the TensorBoard. So as I'm running a TensorFlow job, there's different checkpoints, and you can log information, and that's what TensorBoard is doing, and it can give you a graph of how the training went from this. So it's going a little slow. I don't know if that's the Wi-Fi here. Let's try reloading it. While that's going, let's kind of take another look at some of the other experiments. So this comes back to that question about reproducibility. How do I see all the experiments that I've run, see the results? So this gives you a user interface where you can sort of look at the different runs that you've made and their values. Yeah, things are a little bit slow here, but anyway, what this would show you is just a list of your runs, timing. You can drill down into the view the accuracy and stuff like that. Okay, so that's pretty much an overview of what's in the Kubeflow UI. Let's come back to the presentation briefly. Okay. All right, So just to summarize what we talked about today, Kubeflow's Kubernetes-based machine learning framework that hopefully will allow you to have more reproducible AI. It's open, so we're just beginning the journey. We have contributors from many companies. It's an open community. We invite all of you to try it, see if you like it, and contribute to access it. There's the website, GitHub, Slack, Twitter. There are lots of different ways to communicate with us. We even have a community call every other week where people from the community dial in via Google Hangout, and we kind of talk about the project, take the feedback into account, things like that. So appreciate your time. If you want to reach me on Twitter, that's my handle. Thank you very much.